Okay folks, welcome to Statistical Reasoning Part 2. In this session, as promised, we're going to look at the work of Cobb and McLean. Let's not wait, let's start straight with Cobb and McLean's work. It's a paper published in 2004 and it's based on research that's done at an elementary school. Not in high school, elementary and middle school level. So the principles of instructional design for supporting the development of statistical reasoning is what this paper is all about. These principles that support statistical reasoning, design principles, obviously. Okay, so let's see. EDA is exploratory data analysis. Well, Cobb and McLean claims that exploratory data analysis should be the initial focus of statistical instruction, since it is concerned with trends and patterns in data sets and does not involve an explicit consideration of sample population relationships. Now that's a mouthful. What they are saying in plain English is we need to explore. We need to take data into the classroom and explore the data with the learners, identify trends and patterns in these data sets. It's pretty much what maths does. Maths is the science of pattern. And in statistics, we can talk about statistics as a science of trends and patterns, but in a data set, not in relationship between numbers and that type of thing that we do in maths, but within a data set. Crucial understandings that students should develop center on the relationship between the legitimacy of conclusions drawn from the data and the soundness of the processes by which the data were generated. Okay, so you cannot make a claim about something that you observed if the way in which data was collected, the soundness of that process is not known or is not made explicit. The two are linked to each other. Okay, and that comes in sampling. Later on we'll talk about that when we look at sampling. So initial assessments showed that learners based their analysis by number crunching only, again the mathematical or the mechanical mathematics, and relied on statistical methods that they were taught rather than reasoning about the data and about the things that they observed in the data. So they had their set of data and immediately, let's find the mean, let's find the median, let's find the mode. Instead of looking at the data, just standing back, seeing what trends the data is showing, and if there's certain patterns that are appearing in the data, clustering, skewness, that type of thing. Okay. Initial conclusions also showed in their research that learners could base informal findings by analyzing the distributions that were given to them and were reasoning about the data rather than attempting to recall procedures. So there was a definite shift in their research from children wanting to number grab, formula grab and do mechanical mathematics to standing back, looking at the data by looking at the and analyzing the distribution and then reasoning about what it is that they see in the data. Okay, so the principles of instructional design, we're still busy looking at that, for the development of statistical reasoning. They divide this into 5 big parts. The central statistical ideas deals with the distribution as an overarching statistical idea. Okay, folks, now they say bivariate data sets as distributions can be studied. That shows trend quite nicely. So the central ideas, such as distribution, can serve to orient the development of an instructional design in an activity that you want to take into the classroom as a teacher. Okay, but it must be centered around central statistical ideas that you want to work with. Second key point that Cobb and McLean talks about is instructional activities. The investigative spirit of data analysis must be fostered in the classroom through the design activity, the activity that learners are engaging in. You must make it possible for the students' classroom activity to be imbued with the investigative spirit of data analysis. Not just, this is what we see, this can you see at that point this is happening, can you see that this point is very far. Those are things you want learners to talk about through looking at the distribution of the data that you have given and provided them with. Focusing on significant statistical ideas, very important again. Enable teachers to achieve their instructional agendas by building a range of data-based arguments that students produce. Okay, so those are the instructional activities that we have, that we put into the design of what it is that we're going to do in the classroom. The classroom activity structure is another point that they highlight. The classroom structures that support the development of students' reasoning about data generation as well as data analysis. So it's not about just giving them data to work with, it's about posing a problem, okay, talking them through the data generation process that will answer the problem. What type of data do we want to collect? How much data do we want to have to answer a problem that the teacher is posing to the learners? The data collection as well as data generation. Okay, so data collection and data generation are two different things. Okay, so you must develop students' ability to collect and to generate data. Tool use. Which tools do we use in class? Are those tools appropriate? Compatibility with students' current reasoning. For tool use, the characteristics of data analysis tools fit with students' reasoning when they are first introduced in an instructional sequence. Okay, so the importance of the tool must be compatible with students' current reasoning and abilities to reason. Okay, don't choose a tool which is way over their head. They don't even know how to use the tool, what it is used for, and what it does for them. Support the development of students' reasoning. Serve as a primary means, your tools for supporting students' development of increasingly sophisticated forms of statistical reasoning. So you just don't pick a tool and take it into the classroom and work with it. There must be a purpose. The tool must be appropriate and compatible with the current level of reasoning, and it must also support the development of students' reasoning forward from where they are currently. So that brings a very important point to the table. The sequencing and the use of tools in the classroom. How do I sequence the tools? How do I use them? Very, very important to think about that when you design activities that fosters statistical reasoning in a classroom. Okay, the next point is classroom discourse. Classroom discourse is arguments. How do I construct an argument? How do I present my argument? How do I talk about what I'm seeing in front of me? Okay, all of that happens in the classroom. So there's a certain norms for statistical argumentation. You cannot make a claim unless you can prove it from your data. Okay? So statistical arguments explain why the way in which the data had been organized gives rise to insights into the phenomena under investigation. Okay? Then focusing on significant statistical ideas again. The same as with instructional activities. It's huge, it's important, it's going to repeat itself over and over, you're going to hear the same point. Students engage in sustained exchanges to focus on significant statistical ideas. So this is especially part of collaborative learning, is that focus and that building of shared ideas, challenging one another's ideas in class, not just believing something because somebody claimed it that gets a 6, 18, 90 for maths. Question it. Why is that the case? Where is it shown in the data? Developing a critical eye in a young learner develops the ability to reason about the tool that they're working with. Okay. Cobb and McLean have said that these principles don't stand alone. These principles are highly interrelated. They are connected. They happen in support of one another. The instructional activities, as they were actually realized in classrooms, depend upon the overall goal for doing statistics. In other words, to identify patterns in the data that are relevant to the question or issue at hand. Pretty much like you do it in the normal maths class, looking for regularities, looking how things change. Why do they change? Okay, so the overall goal for statistics must be clear in the head of the educator, in the head of the person that designs these activities, and that is to identify patterns in the data that are relevant to the question or the problem that the learners are solving collaboratively. Also important is the structure of classroom activities. Talking through the data generating process is very important. It forms part of what we do with learners in a classroom to develop their statistical thinking and literacy. So very, very important. That's an example of the structure of classroom activities. Part of that structure should be talking through the data, discussing it, discussing general ideas that learners might see in the data, questioning it and opening up that discussion in class. Then obviously the computer tools that the students use to conduct their analysis, very important, carefully planned. We'll talk about the tools later on, the electronic tools that exist. So you have to make space for the use of those tools, and not just any tool, an appropriate tool. It could be an online tool, it could be a software package that you use. Okay, but carefully plan it and make sure that the tool is appropriate. The nature of the classroom discourse is also part of the planning. Example, engaging in discussion. Which significant statistical issues emerge as topics of conversation? Make notes of them going forward. When you use that activity again in a class, you know what to expect. It's always going to be difficult the first time an activity is used in a class, because you as a teacher reacts to what students are giving you and works with what the student gives you as feedback of their understanding. So yeah, plan the classroom discourse very carefully. Keep it not tight, keep it open, but keep it focused on significant statistical issues. If we look at the work of Garfield and Bensvie, 2004, they talk about statistical literacy, reasoning and thinking. They make us aware that in the United States, the NCTM standards recommended that instructional programs from pre-kindergarten through to grade 12 focuses on statistical reasoning. The goals of their suggested mathematics curriculum include formulating questions, collecting, organizing, and displaying relevant data to answer those questions. But it is not the teacher that only formulates it. The students can formulate questions that can be addressed through the data, and then decide which data needs to be collected to answer that questions. We want to see how many students arrive at school late, 15 in a period 15 minutes after the first bell has gone. What do we need to do to go and generate that data, to go and collect that data that we're going to use to answer that question? Okay. Select and use appropriate statistical methods to analyze the data. Okay, so that's important in the quest to develop statistical reasoning. Develop and evaluate inferences and predictions that are based on the data. This is huge, folks. This is the teacher's job. And it's a difficult job. What type of questions do you ask learners to develop and evaluate inferences and predictions that are based on the data? If the students aren't responding, you need to think about what is the type of question that I'm going to ask to get this thinking going with my learners. And also then to develop the understanding and application of basic concepts in probability. That formed part of their goals in their statistics curriculum. Okay? Traditional approaches of teaching statistics focuses on skills, procedures, computations, things that the calculator can do, which do not lead students to reason or think statistically. Now we know, those of us that's been teaching statistics and statistical reasoning to learners, that we have to teach learners the calculator skills. We have to teach them how to find the line of regression, because that's the only tool that they have access to. They don't have a laptop or a tablet to do their statistical reasoning on. They've got their little calculator. So there is a part, or there is a place for using that as the tool. But that should not be just staying there, the use of that tool, and how do I do this? Why do I do this, and what does it mean? What does it tell me about the data? So moving away from the traditional way of doing things into a more explorative, questioning, critical thinking space with our learners. Let's apply a few definitions. What do we mean by statistical literacy? You can see the two lines that are underlined in that paragraph is understanding. Understanding. What do they understand? Okay? So includes statistical literacy, includes the basic and important skills that may be used in understanding statistical information or research result. Understanding statistical information. Being able to make sense of it. Being able to analyze it. These skills include being able to organize data, construct and display tables, and work with different representations of that data. Okay? So it's all about organizing, constructing, displaying, and working with different representations. That is statistical literacy. And working with it in a way that it develops the student's skills in the statistical classroom. Statistical literacy also includes understanding of concepts, vocabulary, the language we use when we talk about data, and symbols, and includes an understanding of probability as a measure of uncertainty. That's huge. Okay? That is why probability is so difficult to teach, because it measures uncertainty. Then we get statistical reasoning. I've underlined there the way people reason with statistical ideas, not just apply or use them. Understand and being made able to explain processes and interpret statistical results. That is, in a broad sense, what statistical reasoning is. So the author says statistical reasoning may be defined as a way people reason with statistical ideas and make sense of statistical information. This involves making interpretations based on sets of data, representation of that data, and statistical summaries of data. Now I want to say appropriate statistical summaries. Statistical reasoning may involve connecting one concept to another. Example, center and spread, mean, standard deviation. Or it may combine ideas about data and chance. Reasoning means understanding and being able to explain the statistical processes and being able to fully interpret the statistical results. The last slide with the definitions, I want to use my highlighter here. Statistical thinking is an understanding of why and how statistical investigations are concluded, and the big ideas, we're going to look at those big ideas just now, that underline statistical investigations. Okay? These include the omnipresent nature of variation. Variation is a huge, huge concept in statistical thinking, in statistical reasoning, and when and how to use appropriate methods of data analysis, such as numerical summaries, when is it appropriate, and visual displays of data. It takes a clear understanding and a clear thinking about what it is that you're working with. Statistical thinking is an understanding of the nature of sampling. What is the sample? Is the sample generalizable about the population? So if there's 5 coming late, how many came late because the taxi didn't arrive? Can I then, if it's 1 in 5, then 1 in 10 and 1 in 20 the next day, can we generalize that to the population? How we make inferences from samples to populations, and why design experiments are needed in order to establish causation. This is big, especially when you look at bivariate data. Does the one variable cause the other? Is it the taxi that caused the child to be late, or was the child late in the first place and caught a later taxi? Okay. It includes an understanding of how models are used to simulate random phenomena, how data are produced to estimate probabilities, and how, when, and why existing inferential tools can be used to aid and investigate processes. Okay, statistical thinking also includes being able to understand and utilize the context of a problem, informing investigations and drawing conclusions, recognizing and understanding the entire process, from question posing to data collection, to choosing, analysis and testing assumptions, etc. Finally, statistical thinkers are able to critique and evaluate the results of a problem solved or of a statistical study. So if you are able to think statistically, you can look at results, critique them, and evaluate their validity based on issues like sampling, based on how the data was generated. Okay, that brings us to the end of part 2. I suggest that if this was a bit overwhelming, folks, read the Cobb and McLean article, and then maybe just watch the video after you've read it again. It is a seminal article, and it appears in a lot of the readings that we are using when we're trying to understand statistical reasoning. If you learned something, like the video, subscribe to my channel, and share the video with somebody that you think might appreciate this information. Thank you for watching.